Good day, ladies and gentlemen. Welcome to Code Switching 2020. Today we continue with our grade 11 physical sciences, looking at Newton's law. Today's question states the following. A constant force of 180 Newton is employed in the diagram to lift two mass parts, A of 9 kg, B of 7 kg, which are connected together by a string. Ignore the string masses as well as friction. So question number A states the following. Create a separate diagrams illustrating the forces operating on A and B. In number A, we need to draw our force diagram. Number A. What are the forces acting on A? Here we have our diagram. Diagram A. We have weight, which is acting downwards. And we have the tension from the string. Those are the two forces acting on diagram A. What are the forces acting on B? We have B. We have the applied force of 180 acting upwards. Is the force applied of 180. And again, we have weight. Weight will be for the two parts, which is A and B, will be our weight. And also, it's a weight of A, a weight of B, and the downward force of the string, which will also be by the force of A. Then we say this one will be the force of A. Or we can say the force of the tension from A. So that will be the two forces acting on B. So let's look at question number 2. Determine the system's acceleration. For us to be able to determine the acceleration, we know that we need to get the resultant force, all the forces acting on the system, equals to mass multiplied by the acceleration. So, what are the forces acting on the system? Is the force applied minus the weight. Let's take upward as positive. Let's take upward as positive. Hence, weight is acting downwards is minus weight. Will be equal to mass multiplied by the acceleration. Our applied force is 180 minus our weight, which is the sum of all the masses. It's 7 plus 9 multiplied by the gravitational acceleration, which is 9,8, will be equal to the masses, which is 7 plus 9 multiplied by the acceleration. So when we punch on our calculator, (180) minus 7 plus 9 multiplied by 9,8, we are going to get 180 minus 156,8 will be equal to 9 plus 7 is 16 acceleration. So 180 minus 156,8, we got 23,2 will be equal to 16. A. When we need A, we divide both sides by 16. Divide both sides by 16. Therefore, our acceleration will be given by 23,2 divided by 16, which is 1,45 meters per second squared upwards. So let's look at question number 3. Determine the tension in the cord connecting the two mass parts. We need the tension, so we'll be looking at 9 kg. So our main forces are acting on 9 kg is the tension and the weight. So to get C, we'll say the resultant force, all the forces acting on 9 kg, will be equal to mass multiplied by the acceleration. And the resultant force will be the sum of what? Of the tension acting upward minus the weight. Tension is going up, it's positive. Weight is going down, is negative. And F is given by MA. What is our mass? It's 9 kg. Our acceleration is what we calculated to be 1,45. 1,45 will be equal to the tension minus the weight, which is going to be 9 multiplied by 9,8. 9 for the mass, 9,8 for the gravitational acceleration. Then 9 multiplied by 1,45, we're going to get 13. This is 13,05 will be equal to T minus 9 multiplied by 9,8. We're going to get 88,2. Then we transpose 88,2 this side. Our tension becomes 13,05 plus 88,2 equals to our tension. Therefore, when you add 13,05 plus 88,2, what do we get? We get 101,25 Newton. What is the direction? Upwards. So let's do a recap. Today's question stated the following. A constant force of 180 Newton is employed in the diagram to lift two mass parts, A of 9 kg and B of 7 kg, which are connected together by a string. Ignore the string masses as well as friction. Question number A. Create separate diagram illustrating the forces operating on A and B. Forces operating on A, which is this one, is the tension and the weight. And forces operating on B is the applied force minus the weight of B and the weight of A, which are acting downwards. Number B, determine the system acceleration. So, to determine the system's acceleration, we need the resultant force, which are the forces acting on the system, will be equal to mass multiplied by the acceleration. The forces acting on the system will be the force applied minus the weight. If upwards is taken as positive, then our applied force is 180 minus, we add the masses, which is 7 plus 8 multiplied by 9,8. Will be equal to 9 plus 8 multiplied by the acceleration. Then our acceleration we calculate it to get 1,45 upwards. Question number C said determine the tension in the cord connecting the two mass parts. So when we need the tension between the two, we just look at diagram A. We know that the force is acting here is tension and the weight of 9 kg. Then we said the resultant forces, our forces acting on A is MA. The resultant force will be tension minus weight. Then we substitute the masses multiplied by the acceleration equals tension minus weight. Then we did the calculation. Our tension was 101,25 upwards. So that will be all for the day. Thank you for watching. For more videos, please go to Code Switch in 2020. Thank you.